Hey everyone, welcome to physics. I sent out a force and magnitude practice worksheet. It is inside your electrostatics folder inside OneNote. So let's take a look here. So, review. I know this is probably drilled into your brains at this point, but just for fun, we're going to review a little bit. So, like charged objects will, well, a like charged object, an example, like letter A there is positive, positive, negative, negative. If they are like, it means they are the same thing. So things that are the same don't like each other. So like charged objects are going to repel. Okay. And if that goofs you up, just say, like charged. It just means that they are the same. Okay. And then oppositely charged objects, well, that's like a positive and a negative. Those, they like each other. So those are going to attract. Okay. And then charged objects attract neutral objects. So positive, neutral, negative, neutral. So just that quick little review. Like I said, I know you probably could say it to me in your sleep, but just in case, we just want to make sure we're all on the same page here. So scrolling down a little bit. If distance is the same, meaning does not change, okay, does not change, nope. Okay, force and charge have a direct relationship. Okay, direct relationship. That's like two thumbs up. One goes up, the other goes up. One goes down, the other goes down. Okay, so these bullets say if you have two charged particles and increase the charge on one or both, force will increase. We'll take a look at specifics in a little bit, like specific numbers, but just understand that if you're going to increase the force on one, force is going to go up. If you increase the force on both, force is going to go up. It does not matter. Second bullet here, it says if you have two charged particles and decrease the charge on one or both, force will decrease. And again, we're going to look at specifics with numbers in a little bit, but just understand that it's that direct relationship which causes, if one charge is decreased, force is going to decrease. Two charges are decreased, force is going to decrease even more. Okay, so just understanding that direct relationship. One thing before I go any further, I want to scroll back up here a little bit. This word here, magnitude. Okay, fancy word. It just means, don't forget, it means like how much, or in our case now we're talking about charges, how strong the charge is or weak. Okay, it's just how much, how strong. So don't let that word goof you up. I just don't want you to see it and think, oh man, I don't know what that means. Okie dokie. So now we're going to look at examples of increasing force with just numbers that we've got placed here. Okay, so number one says two positive particles are placed a certain distance apart. Remember, if distance is the same. So it says a certain distance. The distance doesn't matter as long as it doesn't change. Okay, so that's why I didn't give you a number there. I don't want you to focus on the distance number. What I want you to focus on is the force and what's going on if you mess with the charges. Okay, so it says the force between them is 10 newtons. I'm going to highlight that. And one of the charges is increased 3 times. The other stays the same. First question, do the particles attract or repel? Well, if you circle back to that first question, it says two positive particles. So you got a positive particle in your left hand, positive particle in your right hand. And if you look back to the review, two positive things, they do not like each other. So they are going to repel. Okay. If you want to write this little extra piece, they repel because both are positive. Okay, just to help yourself. Letter B there, it says, what is the new force? Show your work. Well, your original force here is 10 newtons. Okay, you are increasing it 3 times, so that you got to multiply. So you are taking that 10, increasing it 3 times. And I hope you're not using a calculator. Flex your brain. 10 newtons times 3, well, it's 30 newtons. So my new force is going to be 30 newtons. Okay? Should be easy peasy, I think. I hope. So let's look at number 2. 2 negative particles are placed a certain distance apart. Again, distance doesn't change. We're not going to focus on that. The force between them is 8 newtons. One of the charges is increased 2 times. The other stays the same. Do the particles attract or repel? We'll circle back. You got 2 negatives. So again, negative in your left hand, negative in your right hand, no likey. So they are going to repel. Okay. If you want to write this next piece, go ahead. They repel because both are negative. Okay. Letter B. What is the new force? Well, your original force between them is 8 newtons. Okay. It is increased 2 times, meaning you got to multiply by 2. So you got 8 newtons here times 2. No calculator. Use your brain. 8 newtons times 2, well, that's 16 newtons. Okay? So you should see a pattern here. If you've got, a force and you're increasing it, you're going to be multiplying. So let's check out number 3, last one here. 2 positive particles are placed a certain distance apart. The force between them is 15 newtons. I'll highlight that. One of the charges is increased 2 times. The other is increased 3 times. Okay, so this time we have to think about both of the charges here, not just one. Doesn't make it any harder. We just got a itty bitty extra step. So letter A there. Do the particles attract or repel? Well, circle back. You've got 2 positive particles, positive things. If you've got 2 of them, they don't like each other, so they're going to repel. I'm not going to write that extra piece because we already talked about it. What is the new force? Well, we have to take into account that both charges changed. So my original force is 15 newtons, and one charge increased 2 times. Well, business as usual. 15 newtons times 2 is going to get me 30 newtons. But I can't forget, the other charge increased also. So this charge also increased, but it increased by 3 times. So I have to take that 30 newtons and multiply it by 3 to get me 90 newtons. So my final new force is 90 newtons. Don't stop at that first piece if you have manipulated both of the charges. Okay? So far so good, I hope. So while we looked at increasing, let's check out decreasing. So it says, 2 positive particles are placed a certain distance apart. The force between them is 10 newtons. I'll highlight that. One of the charges is decreased 2 times. The other stays the same. Do they attract or repel? Circle back. What kind of charges do you have? You've got 2 positive ones, so they're going to repel. Okay, what is the new force? Well, your original force is 10 newtons. This time, though, it didn't increase, it decreased. Well, if you multiplied when you increased, you have to divide when you decrease, and you divide by the number. So 10 divided by 2 in your head is 5 newtons. Okay, let's look at number 2. 2 negative particles are placed a certain distance apart. The force between them is 8 newtons. One of the charges is decreased 4 times. The other stays the same. Do the particles attract or repel? Circle back. You've got 2 negative particles, so they're going to repel. Okay. 8 newtons. Oh, B, it says, what is the new force? Show work. Well, your original force is 8 newtons. And this time, again, it decreased by 4. So you see that word decrease, you got to divide by 4. And then 8 divided by 4 is 2. Okay, easy peasy so far, I hope. Number 3, 2 positive particles are placed a certain distance apart. The force between them is 20 newtons. Okay. One of the charges is decreased 2 times. The other charge is, oops, that should say decreased. Sorry about that. Decreased 5 times. Copy and paste got me. Do the particles attract or repel? Well, 2 positive particles are going to repel. Letter B. What is the new force? Well, your original force is 20 newtons. And one of the charges decreased 2 times. So you got to divide by 2. And 20 divided by 2 is 10. But we can't stop there because the other charge changed also. The other charge decreased, change that please, 5 times. So 10 newtons divided by 5. 10 divided by 5 is 2 newtons. So my final force here is 2 newtons. Okay. So using these notes, okay, it's your turn to figure out whether the force increases or decreases. Okay. So I'm going to stop the video here. And if you have questions, please email me. I look forward to hearing from you.